Okay, we get started, folks. Swap places this week. Malcolm is going to run the seminar programme, but since Malcolm is the speaker this week, I'll do a few brief words of introduction. Somebody pointed out we've got a kind of unique combination of individuals here today. We've got Malcolm, who's the seminar speaker, we've got myself, who is his ageing ex-PhD supervisor, and in the front row we've got John Brown, Astronomer Royal for Scotland, who's my PhD supervisor. So we've got several generations of solar sail enthusiasts in the one room, which is a kind of unique combination of people. So, as the young guy by some margin, I'll hand over to Malcolm to kick off his talk.
Thank you, Colin. Well, thank you for coming along. Most speakers say thank you for the opportunity, but as I gave the opportunity to myself, thank you for giving up your time though to come along. So, a brief outline of what I'm going to talk about today. I'm going to talk through, first of all, an introduction to solar sailing. There's quite a wide range of knowledge of solar sailing in the room, from people who have written textbooks on it through to people who have got a basic concept. So I'll introduce that to you. But one slide on performance metrics so you understand the content that comes afterwards. And then I'll talk through the main part of the talk, which is this mission catalogue, a technology development route for the idea of solar sailing, because it's not a new idea, it's been around a long time. How are we going to make it happen? And then, actually, how are we going to make it happen? What's the vision? What's the thing I'm trying to get across in this talk? So, briefly, an introduction to solar sailing. Well, light pressure itself is a fairly counterintuitive idea. You don't turn on a light and go, oh, geez, oh, turn that light off. You know, you don't quite get it at first. But in 1619, Kepler proposed that the tails of comets were being pushed by the sun. This was something he observed. He didn't really explain how he thought it would work, but he looked at it, looked at what was happening, and thought, yeah, that makes sense. Then, 1690, Huygens proposes that light travels as a wave, and shortly afterwards, Newton says, no, it's a particle. And so there's these two quite early and competing ideas of what light is, but actually represent fairly accurately what we think of light today. Is it a particle, is it a wave? From there, in 1873, another Scotsman, James Clerk Maxwell, predicts the existence of radiation pressure using electromagnetism. His unified theory. He predicts the theory. And then independently, 3 years later, Bernoulli also predicts the existence of radiation pressure as a consequence of the second law of thermodynamics. In the intervening time, Crookes believes he has built a radiometer that proves radiation pressure. And until fairly recently was cited in lots of eminent encyclopedias as being an accurate representation of light pressure. But if you look at it closely, it spins the wrong way. There was another few years, 1900, in Moscow, before light pressure was actually experimentally validated. So we've got the theory, and we've now got the experimental verification. Round about this time, or just beforehand, the idea of spaceships propelled by mirrors starts to appear in science fiction. Most noticeably, around about this time in France. So it's a vague concept in science fiction, but the idea is starting to form. But it wasn't really until the early 20th century that solar sailing as an engineering concept started to actually be articulated and some numbers put behind it. And that was by Tsiolkovsky, who is really kind of considered the father of cosmonautics, certainly the father of the Soviet space program. Did an immense amount of work. Not as well known in the West as he should have been, but really within Russia is considered on a par with Gagarin, really is that eminent, that important an individual. His work wasn't really that well published outside Russia. Actually, what should have been his seminal paper was published in a journal, and in the same edition of that journal there was a revolutionary article raving against the Tsarist authorities, and the Tsarist authorities made sure that article didn't get out there. So what should have been his seminal work was effectively suppressed through no fault of his own. But then the revolution came, he supported the revolution, he did fairly well out of that, and his work then became much more widely known. So solar sailing then has been rediscovered and reinvented many times since this early time. Oberth, the German, was really one of the catalysts for Tsiolkovsky's work becoming much better known in the West, because he started to duplicate the work that Tsiolkovsky has done, and the ideas, no idea whether he knew of them, he may have, he may not, but the idea was starting to come out there now. Then in the 50s, the concept of solar sailing is reinvented, this time in North America by Carl Wiley, and then shortly after that, the phrase solar sailing is actually coined in 1958. So we've went through the basic fundamental physics, we've got the proof that light pressure exists, all the way through to actually having a nice snappy name that means the idea is actually going to really catch on now. So what is solar sailing? Well, we're going to use light pressure and we're going to use it on our spacecraft to propel that spacecraft. It's a small but continuous force. So we need a very large but lightweight structure to make use of that force. So we've got our thin film, we've got our instant photons, we've got our reflected photons, and we get some reaction thrust from that. Very, very simple idea. Why is this attractive? Well, there's no stored reaction mass. So we should be able to do new high energy or long duration mission concepts. Or we should be able to significantly enhance mission concepts. And a detail that took some time to understand is the fact that we can travel towards the sun and we can travel away from the sun. We can thrust against or with the velocity vector, and so we can increase or decrease the velocity of the spacecraft so we can travel towards or away from the sun. We can only thrust away from the sun, but we can increase or decrease our velocity. But the important point and the attractive point of solar sailing is that the fact that we don't have the stored reaction mass, and this should be able to enable new, exciting mission concepts.